Hello, and welcome to Senior Code Review Buddy. My name is Chris, and today I'm going to be reviewing some chess engine code written by ChatGPT. I've recently been getting back into chess and decided it might be fun to try and get ChatGPT to write a chess engine in Python that I can review. I don't expect this engine to be anything special, as the top chess engines are really amazing, but I think it could be a fun experience, both to write a chess engine alongside ChatGPT and to get to share my review process. Now, if I was just wanting to focus on sort of the AI or the evaluation parts of this engine, I wouldn't get ChatGPT to write everything from scratch. Instead, I'd probably use a already created library, something like Python chess, to handle a lot of the chess basics. But I decided not to use it because I want to have ChatGPT sort of write everything from scratch. Not to be more competitive, but just to be more fun. I ended up having ChatGPT create the engine in stages. And right now I started with 3 parts. And I split them into 3 initial PRs, each of which is going to have its own video. So today I'll be reviewing the basic chess engine. In part 2, I'll get ChatGPT to add a standard chess interface to that, following the UCI protocol, and it will add the ability to also play against itself. And then in part 3, I'll introduce a basic optimization. We'll get it to use alpha-beta pruning. Now, I've tried to make these reviews as close as possible to a normal code review. Before I started the code reviews, I tried to avoid looking at the code too much. I did poke around a little bit and run the scripts though, as I kind of wanted to try and minimize clearly missing code, but tried to keep that all to a minimum. Once I thought I had the code ready to review, I got ready, I hit record, and I started reviewing the code. So you'll be able to see my full code review process. I tried to think out loud the whole time to give you insights into why I left the comments I did and what kind of things I was looking for in the review. Now, before we go into that review, let's look at some high-level information about the first PR. So for this first PR, we're just looking to have a basic engine, which is basically what I asked ChatGPT for. I did have to clarify that I wanted ChatGPT to generate moves for all of the pieces, as initially it only generated pawn moves, and I asked it for tests as well since it initially didn't give me any. So the initial state was 2 Python files, an engine file and a test file. When I ran the engine file, it would start playing a game against itself and printing the board out to console after each move. White would move a pawn, all of the black pieces would then disappear, and the game would be over after 1 move. So there clearly are going to be some bugs we have to fix. And of the 11 tests that ChatGPT gave me, only 7 of them were initially passing. The failing tests are test generate bishop moves, test generate knight moves, test generate queen moves, and test generate rook moves. I ran Python coverage to try and get a rough sense of how much of the code ChatGPT was testing, and it seems to have pretty good coverage. That said, this doesn't mean we've got good tests, but at least we know a decent amount of the code is getting executed in tests, which is a prerequisite for having good tests. Now that we've got alignment on what the starting state is, let's go to the complete and unedited code review. If you want to follow along, you can find a link to the PR in the description below. Alright, so let's go through this code review from ChatGPT, and I'll try to put comments as per normal. Alright, so this is adding v1 of chess engine generated by ChatGPT. So that's all we've got for the comment. It's pretty basic. Let's see what we've got here. Okay, so we start off with the board class. So we've got parse the board from that, and we initialize the turn to white. Okay, so my first thought here is there's only 2 states we can have for turn, whites or blacks. Using it as a character string and having to check each time doesn't seem the best way, because if this somehow gets a value like C, this doesn't make any sense. So I think for something like this, what we probably want is, since there are 2 states, could you convert this to an enum? And that way we deal with having values that don't make any sense. All right. Parse fen. Okay, we get fen. We have a board which is just... Okay, so we get a board which is just an empty list to start for rows and rows. Wait, fen. Okay, this function, because I'm not super familiar with what fen is right now, this seems a bit confusing. This seems a bit complex. Worth documenting a helper function? So if we put a helper function to do this, that might make it a little easier to understand. But, okay, so we get the rows. And then for each board row, okay, so we split it into rows. And then for each row, we do each character in the row. And we check to see if it's a digit. Yep, because if it's a digit, then that is referring to sort of a number of blank spaces. Yeah, so we do blank spaces times the number that it appears. This can't be higher than 9, that's just how the formula. Well, it can't be more than 8, because it's made by 8 chess grid. But this does raise an interesting question of what happens if we get invalid data here. So what happens if, we get a fen that's got a value of 9? What happens if we get an invalid fen? Say a 9 digit somewhere. So yeah, we probably want some validation here, because looking at this, yeah, this is just assuming that the fen is in the right format there, and that everything is good. So there's no error checking here, so we probably want to add some error checking. But assuming that it works out, yeah, we append the characters when the characters, which yeah, this is a similar note here. Similar thought here. Oops. And we verify it's a char we expect. Okay. Okay, so then we've got display, print the board state, just basic thing here. Okay, generate all legal moves. I wonder if it's worth sticking legal in there to note that it is that way, but I guess you could argue that all moves are legal moves by definition. So okay, so we go. Alright, so we go over every square, and we check to see if there is a piece on the position. If the piece... Okay, so if it's white's turn, and we are an upper piece, which means we are white piece, we will try to move it. Otherwise, it means it's black turn, and because it's lower, we will move it. This seems a bit complex by itself. It feels like it'd be a nice thing to move into a helper function. What do you think about moving this into a helper function? Something like piece for, I guess more piece for moving play, just to make it a little clear what we've got there. Seeing it again, I'm also wondering if we should make a constant for these 8s. I mean, the chessboard is kind of known it's 8 by 8, but yeah, let's make these constants. I think we should make these 8s constants. Get super easy for people. Okay. Okay, so if it's time to move, then we come down here. Okay, So we now call the correct function for the, okay, so if we get an inval thing, we just return an empty list. This feels like we should probably raise an exception though. So it's worth raising an exception here. Since that shouldn't get hit, and I don't think we want to hide that here. Yeah. Since getting here would be an error and something is broken somewhere. See, I think if we try to make a move for a piece that we don't understand, we probably want to raise that right away. One thing that I'm not entirely sure about this, but I don't have a better suggestion right now, is we're passing in piece on the positions, and in theory we can just check the board to get the position, to get the piece again. So like, that's the thing, this could, yeah, because it's possible that you could pass in a piece but mess up these two values. So you would then have something weird where it's like, oh, we're generating a pawn move, but we accidentally passed in a square that isn't a pawn. So I'm going to say, since piece can be gotten from the board, since we have C and R, let's not pass it in. Instead, just pull it from the board. That way, we can't have a case where we are passed in a piece that isn't actually at the square R and C. Because one way I could see this happening is just, if you have something somewhere and you mix up row and column, so you've passed in rows, columns, row, and yeah, that seems like it could happen. Okay, so now we get to pawn moves. Generate the pawn moves. So the direction, okay, seeing this again, piece is upper. I feel like we probably want to wrap upper in a helper function, because it'd be easier to see like, oh, if black or if white. So what do you think about having piece is upper in something like piece is white? Now I guess the downside of this is this does mean we would maybe need to make piece a class, because we're just calling this on the string right now. But I think having this, it makes your code much easier to see, instead of if we're the is upper and you have to automatically like, okay, is upper. Is that white or is that black? I think this makes it a little easier. Maybe worth having a small class for pieces. That could maybe be helpful in some other spots as well. Okay. Yeah, and then we're getting the start row. Okay, so okay, yeah, so pawns work a little differently because they always can move one forward if the position in front of them is empty. But also, if they were on their start row, they can jump 2 at the beginning. So that is correct. That seems right to me. Okay, yeah, one thing that is missing here is it doesn't handle the case where the pawn gets to the first or the last rank, and it's supposed to get promoted. So we don't have promotion in here. We seem to be missing the promotion code. Could you add that in? And we've got captures. It's a bit... Okay, I guess, yeah, so we're doing this to make sure that, because they capture diagonally, we are making sure that we don't go out of bounds before we check the bounds. So this is also missing, related to our double square move. A pawn can do a capture called en passant, and we're not handling that here, so I'll add a note about that. It doesn't look like we are handling the pawn. I think it's spelled this way. Excellent. Capture case. Could you add that in? Okay. I also think, yeah, this is a pretty long thing. So I'm gonna say this statement is pretty long. What about moving it? Helper function. Okay, add a few comments. Okay, and now we go to the rook. It generates it through sliding moves. Okay. And yep, it just goes up, down, left, right, sort of across. And bishop goes on the diagonals. Queen does all of them. So looking at that for a second and seeing that we've got sort of this is used up here, and this next, sorry, yeah, this one's here, this one's here. Feels like that might be worth pulling out to a constant. What do you think about pulling the list of directions we slide into a constant? Same for the bishop ones, and the queen can just be both. Yeah, because if we do that, like right now, if I have a small typo here, like let's say I did 0 and -1 twice, we wouldn't notice that the queen, is different than that, so we'd maybe have to fix the 2 spots, or we'd have them working differently. Okay, and now we get to how this actually moves. Now, okay, interesting. So all we actually need piece for here is just to know whose turn it is. Well, I guess it's to see whether it can capture or not. Okay. All right, sorry, let's start from the beginning. So we have a list for the moves. So we will go over the different directions, and then up to a maximum of 8. Okay, so it's a maximum of 8 because that's how many times we could do it. This feels like a while loop is better, because then we wouldn't need the break here. Instead, we could just have the while condition. I think a while loop might be a better choice here. Something like I equals 1. Wow. So it would be yeah, R. Oh wait, I guess it's it's the 2 conditions. So it would be R plus dr times 1 is, oh goodness, yeah, that's a bit of a mouthful, this. I still think the while loop is better, but I maybe need a helper function then to make sure the range is right. Or actually, I guess what we do is something like that. I equals 1. We have this, and then we have our if condition is just this. Our code, and then the last condition would be an R plus equals dr and plus equals dc. What do you think? I'm not entirely sure about this, but I do think using a while loop maybe makes a little more sense. Okay, and then so we see if it is a blank position. Yeah, it's a valid move to go from there to there. And if the position, so I think this condition might be clearer as a helper function, something like is capturable. Oops. Okay. Okay. One thing that I've just realized in looking at these moves. So there's... so these moves aren't all necessarily valid right now. Because what could happen is when we move one of our pieces, our king could become in check after that because they could have been pinned, which means it's not a valid move. So we need, something we'll need to do for all of these. So we'll need to add a check that moving doesn't result in a king going in check. Looking at the functions, don't think we handle inventing moves that leave our king capturable, which would be illegal move. Can you add that functionality? Okay. Alright, so we've got that. So that's something we'd have to do for all of them. We have the break here because if you can capture a piece, you can't go past it. So that break does make sense. Oh, and also the break that if the piece isn't capturable because it's one of our pieces, we can't go there and we can't move further. So those breaks seem right. I'd maybe, I'd maybe write this else a bit different. What do you think about having something like oops? So else, so we know that there's a piece now. So no, there is a piece. So no matter what, this was our last square to examine. So what if we have the break, and then if piece is captured, we'll add move. So we only have the one break instead of the different breaks. So I think having the one break instead of two makes it a little easier to understand that when we hit a piece, that's the last we can use of that one. Okay, and then we'll return them after doing all the directions. Okay, then we generate the knight moves. So I'll just add this note because it'll be for myself to remember. We should make this a constant with the constants. Okay, so we and because the knight just moves in the L shape, we just do the checks. See if it's a capturable piece or if it's empty. If it is, we add it. Otherwise, we keep going. Okay. And generate the king moves. Chris. Make this a constant 2. This one actually probably can use the same thing we used for the queen. Just know that we don't do the sort of checking different numbers with it. It's just doing depth of 1. Okay. And also, now that we see it, this pattern here looks the same as this, which, yeah, is similar to that there. So, sort of, can we move these 3 lines, 109 to 11, helper function for all the generate used call? Because, yeah, they're all doing sort of the same thing of making sure it's within the bounds, checking to see if it's empty or if it's capturable, and if so, they return the move. So probably just do that in one spot instead of writing it out every single spot. Okay. Make a move. Yeah, so you take the move, you split it to your start and end. You get your initial piece. Wait, sorry, so piece is who's moving. So piece is who's moving. Then you set it to nothing. Okay. So this is 3 commands right now. I think we can just simplify this slightly. I think this would get clearer. Let's code as. I think we can just do, yeah. So we'll just take our end piece just equals the start piece. That's the start piece. And then this. So we get rid of the helper variable, which I don't think really adds much. Okay. Undo a move. Okay, and this is doing the same thing where it's got, yeah. So we don't actually need same idea as above. So instead, what we would do is set start square to the end square, and the end square to empty. Okay. This also does make me wonder if, going all the way back up. Yeah, I wonder if instead of being an array of characters, maybe we should make it an array of pieces. Maybe it's a little slower? Probably a little slower, but it might be easier to read. So, that's a thought. No, I'll think about it. Instead of 2D array of columns, now, thinking about it, I think we're probably better off with helper functions that do the conversions. Yeah, let's stick with the helper functions that do conversions instead of changing it, because that seems a little heavyweight. Okay. And evaluate. Okay, so one thing I'm going to say is I don't think evaluate should be part of the board. The board just should be the state. Evaluate should probably be part of the chess engine. I think this probably makes more sense in the chess engine, since it's more what the engine thinks of the board state as opposed to the board state itself. Because yeah, every game engine should have the same board state, but they would all have different evaluations of how good that state is or not. Okay. Okay, and yeah, this is just a very basic evaluation. You just have the standard points for everything, and yeah, we do that. Yeah, I guess 1,000's high enough for the kings. Technically, they're infinity because they get captured, it's over, but we will leave that as is. Okay, so the chess engine. Alright, so we initialize it with a board. Okay, we've got min-max with fixed depth, so if we reach the depth, we just return the evaluation. Otherwise, we generate the moves. Okay, and if you're maximizing, your max valuation starts at negative infinity. Yeah, you go through the board and you find, yeah, you make the move, get the evaluation doing one last depth, and yeah, we flip from is maximizing to is minimizing, so that's a false. It's a little, I mean, this code will change in the not too distant future, but it's a little, yeah, I think changing is minimizing to an enum would probably make this function call clearer. Let's change. Clearer. The passing the false true. Okay, a bit hard to understand. Okay. Yeah, because you got to realize that it's kind of flipping it around. I guess we also could just you pass it and you just do not that. Yeah, I guess. Or maybe we keep bool, but pass in the not of it instead of the hard-coded values. Future Chris, what do you think? Okay. But yeah, the min-maxing is pretty simple. You just go through all of the moves, evaluate each of them to whatever depth you can, and grab the one that gives you the best value. Although I'm also realizing okay. So yeah, because I was going to say this is just returning the value, it's not returning the move, which means we've then got a function here which is quite similar, but it's returning the move, which, yeah, I guess is okay. It is a little different. There's some similar code, but it's not. It's probably easier to have this split than to, yeah, because otherwise we're returning the move every single time there, which we don't gain anything back, so we're not actually going to use any of the moves, we just care about the evaluation. So yeah, that seems reasonable start. So yeah, best move, you start with none. Best value is infinity, negative infinity, and then yeah, you go through all of the moves, you make the move, get the value. If the value is better than what we've seen before, we take it and do it all. Okay, yeah, that seems reasonable. Okay, and then yeah, the main version is we build things like that. Now I don't think we use that part of the fen, which is telling you, yeah, whose move it is, whether you can castle, move position. So yeah, I guess actually that belongs higher up. So yeah, parse. Yeah. Could you also add code to handle the rest of the fen? Yeah, because right now, yeah, we split it and we drop everything in the second half, so we should probably handle that somewhere. Okay, going back Okay, so yeah, so we create the board, create the chess engine with the board, and while it's true, we print the board, we find the best move to depth 3. If there is move, game over. Otherwise, we make the move and we switch whose turn it is. Yeah, that sounds basic. I guess one thing I would think is we probably want to know, is it a stalemate or a draw? Could you add some logic to determine if the game is over? Let's say stalemate or a win for someone. Yeah. Okay, and now the test, and I'll add the one comment. As I mentioned before, the tests are now passing. Please ensure all tests are passing. All right, so we initialize. Okay, so this is just the general setup. We initialize the board and the chess engine. Okay, we test parsing with the expected board. Yeah, as I already commented on, we don't have any invalid test. This is also, yeah, this one's a little weird because, like, if something's wrong here, you have to look at the setup and the parse. So I would actually, yeah, I'd maybe pull the fen into this one, but could you add a test for a non-new game? I think we want to make sure that we work with not just the standard new game. Okay, pawn moves. Generate. Okay, so this is only testing for white. Please test for black as well. Same for the other pieces. Okay, this also doesn't seem the best way to do this check. We know what our expected moves are, and we make sure that the expected moves is the same length as the moves we get, and then we check that each one's in there. So the problem is, if they're not the same length, this will fail, and all we'll know is the sizes are different. We won't know which one was missing. Yeah, I think with this we actually just want to do a set comparison. I think this might be better as a set comparison, since if the size is, if the size is different, we don't want to see the elements for both sets right away. Probably for all tests. Okay, so we've got that. Alright, so rook, same thing. Oh. Yeah, this is only testing. Yeah, this is only testing moving from the starting row, so this isn't testing blocked. This isn't testing captures either, or non-starting row. So we'll add those. This, we seem to be missing tests for non-starting row, moving blocked, and captures. Oops. Pawn passants in particular being a concern for me. Because actually that might be tricky, because I can't remember if our board keeps track of previous moves, so it might not be able to know right now en passant, so it's going to have to do quite a bit of work maybe for that one. Oh, and I'll just add the note there. Yeah. This applies view all tests. That's more for me than for anyone else. Okay, rook. Same idea. I don't know if those are all right. Knight, same idea. Bishop, same idea. Yeah, looking at this again, I wonder if we should have a mapping. Just to make the code a little easier to read, but I'm not quite sure. What do you think about using constants? I was thinking of constants, so I started writing constants for all the pieces. Could be character enums? Maybe? I'm not sure about that. I'd have to check. Okay, and then generate queen moves. Yeah. We got the same issues as before. Yeah. Again, we make sure that we can make a move and undo a move. Yep. We probably want to do this. Because right now, if we just hardcode it, it only moves the pawn. That would work. Could you parameterize this? It all pieces, both sides. Just basically making sure that they are all able to move, no problems. Okay, test evaluate. Initial palette. So I'm not a super big fan of this because this is just, I mean, it's kind of hard coding to our evaluation. But at least for this, that's maybe okay for now. But like if we changed our evaluation function, we'd have to change this. Yeah, I guess that's maybe okay if we know for sure what we consider evaluations. Okay. Test the min-max function. Basic test to ensure it runs. So I don't know if we really need to test this one because it should be getting tested by best move. So it's more, yeah, since this is just testing that it returns, I would be, yeah, I would say, since I don't think we want min-max to be part of the interface, we should probably drop this test as it's simple detail and just rely. I think it's called best move. Yeah, best move. Best move. Especially since for this one we're not actually testing anything other than it gives a value of the type we expect. Okay, test the best move. So you get best move for depth 1, assert that it is a move, assert that it's a tuple. Okay, yeah, so this is, all this is doing is testing that move is the right format. Which I guess we do want to make sure that we're producing moves with the right format. But it doesn't feel quite right. Wonder if we're better off here. Yeah, I'm not entirely sure. This actually suggests that maybe we should be returning a class here. Because then we could just do like a type. Yeah, I'm not quite sure how to fix this right now, but this one gets off a bit of a smell. I'm not quite sure. I'm not sure about this test. I agree, we want to test best move, clearly. But this is just checking the output matches a certain style. I wonder if we give it a chessboard with only one legal move, and then we verify it times that move. So I think that maybe feels a bit better than sort of just checking this format here. Okay. Right, and that's the end of that. So that's 36 comments. Yeah, that's quite a few for... Okay, so about one comment every 10 lines or so. All right, well, that's reviewing part 1. Thanks. And welcome back. That review ended up taking longer than I'd expected. Hopefully you found the process interesting, though. Let me know in the comments if you saw anything that I missed. And stay tuned for the next 2 videos in this series, where I'll review ChatGPT adding a standard chess interface, and then upgrading the algorithm that it's using to find the best move. If you enjoyed this video, please consider hitting the like button below and subscribing. And if you have comments, code you'd like me to review, or ideas about what you'd like me to talk about, please leave a comment below or reach me at chris@seniorcodereviewbuddy.com. Thanks, and have a great day.